Donetsk region, eastern Ukraine. A Russian soldier runs across open ground. He knows something is behind him. He can hear it, a small buzzing sound, high-pitched, closing fast. He runs harder. He cuts left, then right. The buzz does not stop. He does not make it. This scene has been recorded dozens of times across the front lines of Ukraine. Different soldiers, different fields, different directions. The outcome is the same. The drone finds them. These are FPV drones. FPV stands for first-person view. The pilot wears a headset that shows exactly what the drone's camera sees, as if the pilot is sitting inside the aircraft. The drone is guided manually, in real time, from that live feed. It does not fly a preset path. It follows the target. Wherever the target moves, the pilot moves the drone. The average FPV combat drone weighs under 1 kilogram, that is about 2 pounds. It carries a small explosive warhead, typically a repurposed anti-tank grenade or a shaped charge. A shaped charge is an explosive designed to focus its blast in one direction for maximum penetration. The drone flies directly into the target and detonates on impact. Cost per unit? Between $400 and $800, fully assembled, ready to fly. A person running at full speed covers roughly 100 meters in 13 to 15 seconds. A combat FPV drone travels at 60 to 120 kilometers per hour, depending on its configuration. That is between 17 and 33 meters per second. A soldier on foot cannot outrun it, not even close. What the footage shows, and there is a lot of it, is that Russian soldiers on open ground have tried multiple evasion strategies. Some run in straight lines, some zigzag, some dive into shell craters, some throw themselves flat, hoping the drone will overshoot. The zigzag approach occasionally works. FPV drones are manually piloted and require constant correction. A skilled pilot adjusts fast. A less experienced one may lose the target through a sharp change of direction, but the margin is extremely small and the outcome unpredictable. It is not a reliable strategy. The most documented successful evasion tactic is vertical cover, getting inside a building, under a vehicle, or into a trench deep enough to break the drone's line of approach. The drone needs a clear angle of attack. Remove that angle, and the pilot is forced to abort or crash. Trenches and dugouts were the dominant defensive structure of the First World War for exactly this reason. 100 years later, the same logic applies, now against a 4-bladed electric aircraft instead of artillery shrapnel. In the footage from Klishka and similar engagements across Donetsk, Ukrainian infantry units facing Russian positions reported constant drone presence overhead, both enemy and friendly. The sky above the zero line, the forward edge of the battlefield, is now a contested airspace measured in meters, not kilometers. Ukraine did not start the war with a large FPV drone program. It built one from scratch at speed using civilian technology. The components are commercial. The frames come from racing drone suppliers. The motors are off the shelf. The cameras are the same type used in sports action cameras. The flight controllers, the small computer chip that stabilizes the drone in the air, are produced in bulk for the consumer hobby market. A flight controller processes sensor data dozens of times per second and adjusts the motor speeds automatically to keep the aircraft stable. Ukraine established a network of volunteer workshops, military-funded factories, and crowd-funded assembly lines. By mid-2024, Ukrainian sources reported producing over 100,000 FPV drones per month. Individual brigades began running their own drone units with dedicated pilots trained specifically for combat FPV operations. The training curve is short. A pilot can achieve basic combat proficiency in 2 to 4 weeks using drone simulators, software programs that replicate the flight physics of real aircraft. Simulator hours cost nothing compared to live flight hours. This allowed Ukraine to scale its pilot pool rapidly without burning through hardware in training. Russia responded with its own FPV program and electronic warfare systems. Electronic warfare means using radio signals to interfere with or disable the drone's control link. If the signal between pilot and drone is jammed, blocked, the drone loses guidance and crashes. Both sides now operate jamming equipment along the front line. The result is a constant technological back and forth. Ukraine shifts frequencies. Russia adjusts its jammers. Ukraine adjusts again. The drones with the highest survivability in jammed environments are those with fiber optic control cables. Fiber optic means the control signal travels through a thin glass cable rather than through radio waves. A cable cannot be jammed. The drone unspools the cable behind it as it flies and receives commands through the physical line. The trade-off is range. A cable-guided drone can only travel as far as the cable is long, typically 5 to 10 kilometers. Within that range, it is immune to electronic countermeasures. Before FPV drones became common on the Ukraine front, a soldier in open ground was at risk primarily from direct fire, bullets from rifles and machine guns, and indirect fire, artillery shells and mortars. Both require either line of sight or calculated targeting. Both have dead ground, areas where terrain blocks the weapon's path. A soldier in a ditch, behind a wall, or in low ground had meaningful protection. FPV drones do not follow the same geometry. They fly, they go over walls, they enter windows, they descend into trenches, they fit through doorways. In footage from multiple engagements in Donetsk, drones are documented pursuing targets inside partially destroyed buildings, navigating through blown-out window frames and down stairwells. The psychological effect is documented and significant. Soldiers who reported constant drone presence described sustained stress levels that degraded decision-making and unit cohesion over time. Cohesion means the ability of a unit to function together effectively. A unit that is constantly watching the sky cannot maintain full concentration on the ground threat. Both Russian and Ukrainian soldiers have given interviews describing the drone threat as the primary source of sustained fear on the front line, more so than artillery, which is random, and more so than sniper fire, which requires proximity. This is measurable. Ukrainian and independent military analysts have documented that vehicle movement on exposed roads near the front line has dropped sharply since drones became prevalent. Supply convoys now operate primarily at night or under smoke cover. Smoke cover means deploying smoke grenades or smoke generators to obscure visual targeting. Troop movements in daylight across open ground have been reduced or eliminated in many sectors. The infantry tactics that emerged in the First World War, short rushes between covered positions, bounding overwatch, suppressive fire, were built around the machine gun threat. Those same tactics are now being re-evaluated and modified specifically to account for the overhead drone threat. Militaries that have not yet adapted their doctrine, their written rules for how to fight, to include drone threat mitigation, are considered by analysts to be operating at a significant disadvantage. An Abrams tank costs approximately $10 million. A Leopard 2 costs roughly $8 million. An FPV drone costs $500. In documented footage from Ukraine, FPV drones have disabled armored vehicles, destroyed field artillery pieces, eliminated crew-served weapons, and forced the abandonment of prepared defensive positions. Not every strike is decisive. Many miss, many are jammed, but the volume is the point. If one side can produce 100,000 drones per month at $500 each, that's $50 million in monthly expenditure. One armored brigade, approximately 100 vehicles, represents a capital investment of over $800 million. The arithmetic of this exchange favors the drone. Military planners at NATO, the U.S. Department of Defense, and defense ministries across Europe have formally acknowledged this shift. The U.S. Army has accelerated its own counter-drone and drone strike programs. The term being used in defense circles is drone democratization.